Hi everyone. A couple of you asked if I could do a few more of the word equation examples for you, and so that is what I'm here to do. So you can practice with these, and the answer key is here. And if you need some more practice, or if you need some more explanation, that's the point of this video. Okay, so let's jump right in. We have aqueous beryllium chloride. Okay, so beryllium chloride. Beryllium is a metal. So again, and chlorine is a nonmetal, so I'm dealing with a compound here. So I need to look on my periodic table for beryllium. I'm going to see that Be is in the second column. I am doing this off the top of my head. I could be wrong. Okay, beryllium's in the second column, so it's going to be 2 plus, group 2. Chlorine is in group 7, so that's going to be a 1 minus, right? And by now, I'm not going to go through explanations of that. If you need that, go back to that section, look at videos, and do some reading and ask me some specific questions if you have them, because at this point, we're all should be at the point where we can look at a metal and a non-metal, look them up on the periodic table, and tell what their charges are going to be. Okay, so we have aqueous beryllium chloride. So when I write the formula, I'm going to need to write BeCl2 to balance the charges, and that is aqueous. It's going to react with plus aqueous silver nitrate. So this is a funny one, silver nitrate. Silver is a transition metal, and I will tell you this, unless it says otherwise, you can assume that it's going to be a 1 plus. That is silver's most common ion. Okay, so it will give you a Roman numeral if it was going to be a different charge. So silver otherwise would be a 1 plus. I won't try to trick you with ones like that, but this just happens to be the example. Okay, nitrate, ATE means I'm going my polyatomic ions, and that's going to be NO3. So silver nitrate, the charges are balanced, ready at 1 and 1, and again, aqueous solution. Okay, and aqueous. Okay, so they kind of just word it opposite. When they react, these are the products, right? These form. So these two reactants form aqueous beryllium nitrate. So again, beryllium was a 2 plus. I really hope beryllium is a 2 plus. And nitrate is NO3 to 1 minus. So it's going to be BeNO3, and that is aqueous, and it also produces solid silver chloride. Okay, so again, Ag plus, Cl minus, so their charges balance out, and that is going to form a solid, right? And remember, that means that it is a precipitate, so that precipitates out of the reaction. Okay, and that's it for that one, right? That's all we're going. We're going to do balancing equations next, so we're not going to worry about that. We can leave it just the way it is. All right, when isopropanol, C3H8O, burns in oxygen, carbon dioxide, and water are produced. So we have that formula, C3H8O. Kind of a funny way to write that. Normally you would write it C3H7OH because it's an alcohol. I know that because it ends in OL, but that's okay. Doesn't really matter. Okay. C3H8O burns in oxygen, so plus oxygen. Oxygen, have no fear of ice cold beer, of oxygen is diatomic element. Okay, isopropanol usually comes in a liquid form, but yeah, I'm going to go with that. And if you know what, if you don't know, then just leave it out, really. Burns in oxygen. Oxygen usually comes as a gas. We know that. It says carbon dioxide and water are produced. So again, the sentence is written kind of just inverted, but that means they are the products. Carbon dioxide. So now this is not an ionic compound. Carbon is a nonmetal, oxygen is a nonmetal. So I'm looking at the prefixes. So I have 1 carbon and I have 2 oxygens, carbon dioxide. And that is always a gas, and it produces water. And I hope I don't have to tell you the formula for water. I think all of us know that by now. Because this is a combustion reaction, this is also going to be a gas because it's burning, right? And so the water is going to be vaporized in a gaseous form. Okay, and that is it for that one. When aqueous sodium hydroxide reacts with sulfuric acid. So here we have sodium, again, Na plus, hydroxide, hydrogen and oxygen, polyatomic ion, OH minus. So sodium hydroxide, the charges balance out, and it is aqueous. It is reacting with sulfuric acid. And again, if it's an acid, I'm going to give you a formula because we didn't do naming acids, which we may or may not get to at this point. So I'll just always give you the name if it's an acid. Okay, and acids are always aqueous, whether it says it or not. So these are our two reactants, and they produce aqueous sodium sulfate. So again, sodium SO4 is a 2 minus, right? H being plus, SO4 a 2 minus. So sodium sulfate, I'm going to have to balance those charges. I'm going to need 2 sodiums and the sulfate. Okay, and that is aqueous, and it produces water. And water is a liquid, right? Generally speaking. Okay. Alrighty, moving right along. When fluorine gas comes in contact with calcium metal at high temperatures, solid calcium fluoride is produced. Fluorine gas have no fear of fluorine, so F2, right? F2 gas comes as a diatomic molecule. Comes in contact with calcium metal, so calcium in solid form, calcium metal, and it requires high temperatures, heat. Solid calcium fluoride is produced. Okay, so calcium fluoride, right, which means the calcium part comes first, and then the fluorine because it's metal and then non-metal. So let's just take a quick look at this one. This is calcium, which is going to be a 2 plus, fluorine, which is going to be a minus, right? So again, I have a total of 2 positive charges, so I'm going to need another fluorine to make my 2 negatives, right? So this formula is going to be CaF2. So it just happens to be the F2 also happens to be F2. That is totally coincidental based on the fact that calcium is a 2 plus, right? It has nothing to do with the fact that this subscript is a 2. We do not carry subscripts over from the reactant to the product side. Okay, lastly, sodium metal reacts with aqueous iron chloride. So sodium in its metallic form, so solid metal, reacts with aqueous iron 3 chloride. I'm sorry, iron 2 chloride. So that would be Fe2 plus, chlorine is a minus, right? So FeCl2 since it's aqueous, okay? And it's going to produce iron metal, so just iron by itself, metal, and aqueous sodium chloride. And I think we're pretty used to sodium chloride, right? Which is going to be in solution. Okay, so that's it, folks. You literally need to translate. You're a translator for this assignment. You're translating the words into the chemical symbols. And your algorithm, if you will, for translating most of what you're going to be reading is going to be writing the ionic formulas, right? So remembering which ones are ionic, which ones are covalent, and for the ones that are ionic, looking up the charges and balancing the charges. So again, if that is something you are struggling with still, you should redirect yourself back to, when we did that, right? Back in chapters 5, 6, and 7, when we were learning about charges and looking at the periodic table and understanding how the periodic table tells us what the charges of the element and also how we write the formulas for the ionic compounds. Okay, so if you need specific help with that, send me an email. All right, but otherwise, give the worksheet a try. Your assignment here, you've got 15 of them to try. I'm pretty sure I read through them well, and you should know what the state of matter is for all of them. And again, remembering as I give you a note up here, acids are always aqueous. So anytime you happen to see an acid, I think there's 1 or 2 in these, you can remember that those will always be in an aqueous solution. Okay, so have a great day, and if you need extra help, just let me know.